Sup. So today we're going to be doing another top K coding strategy problem. So today we're going to be doing kth largest element in an array. Given an integer array nums and an integer k, return the kth largest element in the array. Note that it is the kth largest element in the sorted order, not the kth distinct element. Yeah. So basically, the second largest number in this array would be 5, so that's why the output is 5. The fourth largest in here would be 6, 5, 5, 4. The output is 4. I think relatively simple. Yeah, so with that being said, I think we can just move on forward. We want to create our min heap here. Actually, I'm not certain if they do this, so I'm gonna do from heap q import all, and then so after we've created our min heap, since this puts the smallest number at the top, the biggest number at the bottom, right? So if we put k amount of elements in the array, then we know that the item at the very top is the smallest thing that we have so far, right? So we can sort of approach it like how we did it yesterday, where we will do for I in range of k, we're going to do heap push, one extra p, min heap and nums I, right? So that way, we'll just run through this example. So k equals 2, so we'll have 2 and 3 in our heap. So 2 is on the top. And so whenever we see a number greater than whatever number's on the top, we will pop off the first number, which is in this case 2. So okay, we'll just run it through, right? So we have this array 3, 2, 1, 5, 5, 6, 4. Our heap will consist of 2 and 3 because it's a min heap, the smallest numbers at the top. We look at the 1, it's not right. It's not greater than this, so we don't care about it. 5 is greater than this, so we'll pop this off. Whoops, I went too far. And then we're going to put in the 5. Right, now we look at the 6. So 6 is greater than 3, so now we pop that off. We put in the 6. Now 4 is not greater than 5, so we can leave it. And now this is our heap. And now we can return this, which is the right number, right? So that's essentially how we want to code this problem. So we've already got the first part where we just get the first two numbers, or first k numbers, sorry. And then for I in range from k to the length of nums, because we don't actually get to this number. It's this part is exclusive, this part is inclusive. So since we never get there, we go to the length of nums minus 1, which is the last number of our array anyways. We have to check if nums I is greater than min heap 0. So going back to the example, actually it's 3, 2, 1, 5, 6, 4. So we start off with 2, 3, sorry. So now for I in range of k, so k is 2, right? So I, if it's greater than it, then that's when we do something. If not, then we don't do anything. So if since 5 is greater than 2, we put it in, right? So this is what we need to do. We need a heap pop off of the min heap, which will pop off the 2, and we're gonna heap push min heap again. Whoops, min heap, and we're gonna push on nums I. Ooh, nums I. There we go. So now we have completed the heap push, and so this will just keep going through all the way toward the end of the array, and then we just have to return min heap 0. So yeah, we basically already so yeah, that just solves our problem. So now if we go here, boom, submit. I guess the runtime is kind of bad, but I mean it solves the problem. It's pretty good runtime complexity because it is O of n log k, where k is the number of items going into our heap. Our space complexity is O of k because we only put in k items into the heap. And yeah, so that's how we would do the problem. and then we're done. Yep. All right. See ya. Thanks for watching.